Thank y'all for attending this session. My name is Jason Handley. I'm the Director of Emerging Technology at Duke. So I think we've already heard some great presentations and work that is going on in the industry. I am taking a little bit different task with this presentation. I'm going to try to go quick because I think it's going to be more interesting in the conversations that we're going to have and the questions we can ask later. Propaganda slides were pretty big. 7.7 million customers that have a meter, about 25 million people, and we have about 1.6 gas customers. You can keep going there. We do have a lot of renewables now. Renewables is one of the areas that we have extremely expanded our goal to do even more. So we've invested about $6 billion so far. We're going to invest another $4.7 billion over the next 5 years. So we're going to be growing to over 8,000 megawatts by the end of this year of under contract renewables, most of that being wind and solar, of course. And we're starting to do more work in energy storage. Please go ahead. So this slide actually is mistitled. It's not the challenge facing the industry, it's the challenge facing the world. And that is decarbonization. Because I am not necessarily a green card holding environmentalist, but I do believe it's true. And I do believe we have to change how we work. And so Duke has actually set a goal of having net zero carbon emissions by 2050. And we're going to have ours to at least 50% reduction from 2005 numbers by 2030. The interesting part about that is we don't have any idea how we're going to actually get to net zero by 2050 yet. There's going to be a tremendous amount of research and technology that may not exist today that's going to be required for us to do that. So when we keep talking about the future electric grid, we're going to be defining that as we go. Go ahead, please. So the challenges facing our industry, you'll see I like word clouds, by the way. One of the things is resiliency is probably one of the biggest pieces that keeps coming up. That's, of course, especially for our territory. We have been hit in the past, 3 years now by 6 major hurricanes. And so that not only affects our customers, it affects folks that have to support us. It affects, we rely a lot on mutual assistance from others. And it also, there's a large cost to go back and rebuild the grid each time. And that cost is generally passed on to our customers. And so how can we look at building a more resilient grid? And in some ways, maybe that's not a fully interconnected grid in the future. We don't know yet. We're going to have to see. Of course, people have talked about cyber. People talk about national security. So the challenges here are going to be really what we're facing in the next few years. I took a turn with this presentation. This is not the original one I sent to Rick. I was going through everything Duke Energy was doing, listing out all the programs and pieces and parts, and I just said that's going to fall flat, I think. I mean, I don't think you really care that I'm investing $25 billion in the grid over the next 10 years. But we are. Go ahead, please. What is important is what we call the energy evolution. And so where we've come from versus where we're going to. And I won't spend a lot of time on this, but it's really about 1890s, we started seeing power plants. And then we started getting into the 50s and 60s into coal and to some gas units. And in the 70s and 80s, we started making those existing plants more efficient. And then in 2000s to present, everything was kind of, we started seeing solar, but not in large numbers. We started seeing wind, but not in large numbers. And if you can tell, everything from 1890 up to the early 2000s was almost linear in its path. We knew how to handle it. Everything went relatively smoothly. Now what we're getting to is we're getting into a bunch of IT/OT conversions. So we still have to understand the operational technology and how we're going to deal with that. But if you see the yellow lines up here, if you can actually tell the difference, that's actually telecommunications. So now we're overlaying telecommunications on most everything we do. Everything we do now has a connection, which again increases cybersecurity threats. The threat vectors change, the more points you're putting out. It also helps us, it also really pushes us to understand how we're going to really manage the grid in the future. And is it even feasible to manage a complete grid centrally? Or are we going to have to do it in a hybrid model where we manage much more out at the edges of the grid? Go ahead, please. So today's grid is pretty common. Yeah, you may have one more click you have to go through. It's things that we've been into, things that we've been we know how to do, but now we're starting to put a little bit more thought through it from the type of wind and solar and even EVs and batteries at homes that are starting to pop up. But the issues that we have is it doesn't really integrate these sources, these new variable sources, very easily. And it can be difficult to maintain. We have failures, as was mentioned, what's happened in California. Things that have happened as far as wildfires go. And it's all manual right now. Yes, there's automation. Please don't ding me and say there's no automation. I know there's automation, but the majority of the repairs that we have to do are going to take an actual physical person going to do something about that. And again, we talked about communications, and communications for us is key from the standpoint of knowing the situational awareness that Sam was talking about. How much can we actually take in, and how much do we actually need to take in? Because we can solve a lot of things locally if we have the right intelligence out at the grid edge, and I don't need to move all the data. There's a cost with moving every bit of that data. There's also a time cost with moving every bit of that data. And the future grid's going to have to figure out what that correct balance is. Please go ahead. But tomorrow's grid is going to be more of an interconnection of a bunch of different, it's going to be actually a conglomeration of a ton of different distributed energy resources. And those resources may be owned by us, but more than likely they're going to be owned by a third party also. And so really, how do we, as the controlling unit or the balancing authority in the area, actually end up managing that properly? So we're going to have to figure that out along with our customers, because distributed energy is not something we're going to be getting away from. It's something we're going to be embracing more and more third parties are going to have to work with us. Now, having said that, I want to tie that back to resiliency. Resiliency has always been the single-minded purpose of the utility. But as we continue to get more and more third-party resources out there that are providing solar, wind, other types of distributed energy resources, they are also going to have a stake in the resiliency of the grid. They're going to need to be there when called upon, because we're making plans now from our advanced distribution planning criteria that we're putting into place now to be able to count on those resources. And if those resources aren't there in the future, we may or may not have that legacy mechanical iron in the ground like a coal plant or a nuclear plant sitting there ready to take up the slack. So there's going to be a need from a policy perspective for us to think through that and how to put more accountability on the third parties to be there when they need to be there. Please go ahead. So one of the things we're really big on is proprietary versus open platforms. You've heard the old saying, I've met the enemy and it is us. Well, that's the utilities. All right, so for years and years and years, we've asked for proprietary platforms, and our suppliers have graciously given us everything we've asked. And what we've done is we've worked ourselves into a corner. And now we can't make a move without going back and asking that supplier to change something for us, increase something for us, make something better for us. And there's a cost and a time for that. So sometimes it's not always the money piece that's the hard part, it's the time piece of that, because I need to make changes a lot quicker. So in the past, what we've done is the rip and replace model. We'll go in through with a proprietary platform. You may have some apps sitting on top of that, and then you'll go back out and push it out to some of your devices. And those devices are what we call it polled in a round robin fashion, or a star method. All right, so you're talking to one device, then it moves and you're talking to another device. Where we're going to have to go is a more interoperable future. And that future, if you will, is based off a couple of different open platforms or open sources in ours. We have been working on something called Open Field Message Bus, or OpenFMB, if you see that. Basically, it's the USB. If you think about a USB, what it did for a computer, we're going to do that for the electrical grid through OpenFMB. It's a publish and subscribe message bus protocol. And so no matter what you talk, whether it be CAN bus, Modbus, DNP3, IEC 61850, whatever it is, we can convert it into an Internet of Things protocol at the grid edge and then share data locally without going back through anybody's head ends. So for me, whether this makes a lot of sense to y'all or not, I don't have to go through a meter manufacturer's head end to get information back at my data center. I can get a meter's information if it is, from a cybersecurity perspective, it has the right security encryption keys out at the edge. So a meter can share data with a capacitor control, with a regulator control, with whatever is out at the grid edge. And then one day, what we hope to be able to do is offer this core platform that the industry will hopefully adopt. And think about that more as a Linux platform. So it's going to be open and interoperable. So utilities, whoever, third parties may want to come in and be able to change some of that core technology, which is potentially. But the real piece for this is up top between the open APIs and the apps. Because what we're really trying to do is we're really trying to take dumb devices or dumb controls that we put out in the field and put industrial grade computers at the edge of the grid. And then make it like a cell phone. You download apps to it. And that app will tell that piece of equipment what it's doing today. And we may be able to make some money as Duke Energy by selling those apps to others, maybe a Schneider. Schneider may be able to make those apps and sell them to us. So it all just depends. But we're having to move down this path for more open interoperability. Last slide, please. So trying to get to the crux of the matter, the future of the electric grid. Well, doing a quick poll of some of my group, this is the word cloud we came up with. What is going to be important to the future electrical grid? I know there's things missing off here, please. Yeah, I got it. But the big thing, storage. Storage is going to be extremely important. One of the things that concerns me, though, is I don't think, personally, I have concerns about lithium ion storage from a safety perspective. I think we've already seen that. So how do we actually do it right? How do we go through and ensure that these large containers that we're putting in with an electrolyte that is relatively volatile within a fence line of a neighborhood is going to be safe, or in the bottom of a building? So the storage is one of those things that we're working very hard on. And we're also looking at non-chemical energy storage. Non-chemical energy storage is something that I think is going to take off in the near future. Of course, V2G is going to be huge. But V2G is going to take a tremendous learning curve for us on the utility side to really understand how to actually take it, use it, and control it in the right way. Think about this. So the first place is, where's the best place to go for a V2G solution? School buses. That's absolutely the best first place to go. Most everybody's done by 5 o'clock. You can throw the excess power back onto the grid. During the summer, you got 3 months of the buses sitting around. And then if we have emergencies, you can roll them back up to schools, plug in, and all of a sudden you've got storm shelters. So V2G is going to be really important for us. Microgrids, as we've talked about, solar efficiency. One thing that's kind of, it's not really, prosumers on there, transactive energy's on there, supply demand's on there, policy. I think Rick talked about this. I may be wrong about that. But I personally don't ever think we're going to get to 100% renewables. That's not because of anything except for one thing. We will have to have a national transmission policy in order for us to get there, because the NIMBY perspective is too much in this town. You're never going to be able to take a huge amounts of solar and wind that are in the Midwest or wherever they're going to be and push them everywhere else they've got to go without a national transmission policy, because we're going to have to figure out how to get them down interstates. Because how many times do you drive down the center of an interstate? Guess what else that's going to help? If we have those large transmission lines down interstates, we're going to now be able to have refueling stations for EVs drop down right outside of there. So anyway, this is some things to think about, and I hope we'll get into some good questions at the end, but I want to thank you for your time.